Okay, flip in your workbooks to page 188. We're going to look at section 7, where we're going to look at right triangles. So we've talked a little bit about a right triangle before. And we've also talked about other ways that we can prove that two triangles are congruent. So let's review those 4 ways that we've talked that triangles can be congruent by. Okay, there are 4 of them. We talked about them in the first set of videos for this section where we have the side, side, side. So if all 3 sides of our triangle are congruent, then the 2 triangles are congruent. And if the second one was side, angle, side. So if we have a side and then an angle, then another side, then the 2 triangles would be congruent. We also had angle, angle, side, and angle, side, angle. Okay, so the difference between these 2 is the placement of the side. Notice in ASA, the side is in the middle of the 2 angles. So this side would have to be between the 2 angles, whereas this side is outside, so it is not between the 2. So that's how we distinguish between angle, angle, side, and angle, side, angle. So these are the 4 ways that we talked about how we could use them to prove that 2 triangles were congruent. Okay, we're going to look at a 5th way today that's called the hypotenuse leg theorem. It's just another way to prove that triangles are congruent, but it only works on right triangles. Okay, so the hypotenuse leg theorem says that 2 right triangles are said to be congruent if their corresponding hypotenuse, that's the side across from the right angle, and at least one of their legs are congruent. So let's look at this right triangle here, A, B, and C. So we have our right angle is at the point ABC. Angle ABC is right. So we have it marked by a box. The hypotenuse would be this side here. So this is our hypotenuse. So it's the side across from our right angle. Okay? So by the hypotenuse leg theorem, it says that if there are hypotenuses and then one leg, so the other 2 sides of a triangle, so this side and this side are both legs. They do not have to be equal. They could be, but they do not have to be. But they are both given the name leg, and then this is the hypotenuse. So by the HL theorem, we have that 2 right triangles are congruent if their hypotenuse and their leg is congruent. So let's look at these 2 triangles a little bit closer. I'm going to erase what I labeled there. So we have 2 triangles, ABC and X, Y, and Z, and they're both labeled as some parts are congruent. So the first thing we're going to look at is this hypotenuse AC is labeled with 2 dash marks. So we know that it's going to be congruent to this side that also has 2 dash marks. So the 2 hypotenuses are congruent. And we notice that the leg AB has 1 hash mark, and then the XY also has 1 hash mark. So we have a leg that is congruent, and we have a hypotenuse that is congruent. So these 2 triangles are congruent by the hypotenuse leg. So let's list these statements to prove that the triangles are congruent by the hypotenuse leg. So we have that side AC is congruent to side XZ. And then we have that side AB is congruent to XY. And that's all we needed to prove that these 2 right triangles were congruent. So let's look at the proof on the right side of the page. So consider the triangle SQR and triangle RPQ. In the diagram below, complete the 2-column proof. Remember, a proof is just us showing what we know. and why we know that it's true. So we're going to start out with some things that are given. So we're given that triangle SQP and triangle RPQ are right triangles. Okay? And that SP is congruent to QR. So I'm going to go ahead and label those. SP is congruent to QR. And we want to fill in these missing statements and the missing reasons. So looking at our statements first, we see that triangle SQP and triangle RPQ are right triangles. Well, how did we know that? Well, it was given. So that was the given. Okay, we need our second statement now. Well, we're given that the reason for that statement is given. So what else were we given other than the two triangles are right triangles? Well, we are given that SP is congruent to QR. So we'll fill that in here. SP is congruent to QR. Okay. Then next, we have by the reflexive property of congruence. What does our reflexive property mean again? Yes, it means that two things are congruent to itself. So PQ would be congruent to PQ. It's like saying 1 is equal to 1. It's always true. Okay, so PQ is going to be congruent to PQ. Why are we using PQ? Well, because it's the side that is shared by both triangles. So this is a leg of both of our triangles, and we have that the hypotenuses are already equal to each other, or congruent. So we have that the two triangles, SPQ, is going to be congruent to RPQ. How? Well, it's by hypotenuse leg theorem. So the HL theorem. Just like that. Okay, so let's slide over to the next page. Okay, so let's look at that first problem where it says consider the following diagrams. So we have two triangles where this one is x, this is x plus 3, this hypotenuse is 3y, and this is y plus 1. It says find the value of x and y that prove the two triangles are congruent according to the HL theorem. So we want to use our HL theorem. Well, what does that say? It says that our hypotenuse and the leg of the triangle are congruent. So let's start with our hypotenuse. What is my hypotenuse of this triangle on the left? It is this long side across from the right angle. So it's equal to x plus 3. What is my hypotenuse of this right triangle? Well, it's also this side across from the right angle, which is 3y. Okay, so we have x plus 3 is equal to 3y. Okay, next we want to set the two legs equal to each other. Well, what is the length of one of my legs of this triangle on the left? Well, we're given this one is x, so we have x equal to, and then the leg that's given on this side is this one where it's y plus 1. Okay, now we want to solve these two equations for x and y. Okay, we notice that we have variables in both of them. That's okay. We can use this just like we did in Algebra 1. So we already have that the brown one is solved for x, so let's plug this one into here. So we'd have y plus 1 plus 3 is equal to 3y. So 1 plus 3 is 4, so y plus 4 is equal to 3y. Subtracting y, we get 4 is equal to 2y. And then lastly, we divide by 2. So y is equal to 2. Okay, now let's take this value, and I'm going to plug it in right here to that brown equation, x equal to y plus 1. So I'd have x equal, well, what's my y value? 2 plus 1. So x is equal to 3. So I have that x is equal to 3 and y is equal to 2. I solved for both variables, just like it asked. Alright, now let's go over to the other side of that page and look at the try it proof. So it says consider triangle A, B, and C and triangle ADC in the diagram below. Complete the 2-column proof. So we're given this diagram and it says given that AC is perpendicular to BD. So AC is perpendicular to BD. And AB is congruent to AD. So we'll go ahead and mark all of that information. Okay, we want to prove that triangle ABC is congruent to triangle ADC. So AC is perpendicular to BD is our first statement. Well, that was in our given right here. Next, it says that angle ACB and angle ACD are right angles. ACB, ACD. Well, they're right angles. Why? Well, because AC is perpendicular. So it's by the definition of, I'm going to shorthand, perpendicular lines. Remember that T upside down just means perpendicular. Okay, next line says that AB is congruent to AD. Well, that was the other part of our given, so we already had that information. Okay, moving to the next statement. Okay, so the last statement says that triangle ABC is congruent to triangle ADC. Well, how are these two triangles congruent? What information did we find or were given before that we can now use to show? Well, we already were given that AB is equal to AD. They're both congruent, so we have that the hypotenuses are congruent of the triangles. Okay, to use our HL theorem, we would need that that two legs are also two legs, meaning one leg from each triangle, are congruent. Well, we see from the diagram that they share the leg AC. So they have the hypotenuses that are congruent. We know that something is congruent to itself by a reflexive property. So we have the hypotenuse and we have a leg that is congruent to each other. Therefore, the two triangles are congruent by HL theorem. Okay, let's flip over to the next page. So we're going to look at page 190. And let's look at problem number 4, where it says consider the diagrams below. Find the values of x and y that make the right triangles congruent. So when are two right triangles congruent? Well, when their hypotenuses equal each other, and when one leg from each triangle is also equal to each other. So let's first set our two hypotenuse equal to each other. So we'd have 3x plus y is equal to y plus 5. Remember, our hypotenuse is across from our right angle. Fun fact, it also is the longest side of a right triangle. Then we want to set two of our legs equal to each other. So one from this triangle and one from this one. So we'd have y minus x is equal to x plus 5. Okay, I'm going to solve this blue equation for one variable so that I can substitute it in. If you would rather use elimination, do that. So I add x to both sides and I get that y is equal to 2x plus 5. So I'm going to take this right here and I'm going to plug it into the purple. So I would have 3x plus y. Well, what is my y equal to? Well, it's equal to 2x plus 5. Okay. Equal, again, we have another y, so that would be 2x plus 5. And then we'll add 5 to it as well. So 3x plus 2x would give us 5x plus 5. 5 plus 5 is 10. Okay, now let's subtract 2x from both sides. So 3x plus 5 is equal to 10. Subtract 5. 3x is equal to 5. Dividing both sides by 3, we get that x is equal to 5/3. So we solved for x, now we need to solve for y. So I'm going to take what we found here, this x equal to 5/3, and I'm going to plug it in to this equation here. So y is equal to 2 times 5/3 plus 5. Well, 2 times 5/3. 2 times 5 is 10, divided by 3 plus 5. How do I write 5 as a fraction with a denominator of 3? Well, 5 times 3 is 15, and divided by 3. So y is equal to 25/3. And that would be our answer. X is 5/3, y is 25/3. So let's recap what we did in this problem. We set our hypotenuses equal to each other. We set the legs that we were given equal to each other. Then we used our algebra techniques to solve for the two variables of x and y. Lastly, let's look at the last problem in this section where it says beat the test. So it says engineers are designing a new bridge to cross the intracoastal waterway. Below is a diagram that represents a partial side view of the bridge. The bridge must be designed so that triangle ABC is congruent to triangle EDC. Engineers have measured the support beams represented by AC and EC in the diagram and found that they are both 120 feet long. So if they're both 120 feet, that means they're congruent. The engineers also determined that the beams AB and ED are perpendicular to the bridge BD. So if AB is perpendicular to BD and ED is perpendicular to BD, those would be 90-degree angles. Lastly, it says that point C represents the midpoint of the line BD. Complete the two-column proof on the next page to prove that triangle ABC is congruent to triangle EDC. So the first statement is going to be something that we're given. What information were we given in this long paragraph? Well, we labeled it as we went along, so we already know. We had that AC was equal to EC, and we were given that AB is perpendicular to BD, and ED is perpendicular to BD. So how do we know what to put in the statement for line 1 when we are given 2? Well, let's read the next one to see if they gave us one as well. Oh, they did. They gave us the perpendicular one. So we're going to include the other one in statement 1, which is that AC is congruent to EC. Okay, so we know that 1 and 2 are our given. We were also, what else were we given? Well, C is the midpoint. C, midpoint. So let's include that as well. Of BD. So y'all put both of those right there at 1. Okay. So 3, our reason is by the definition of a midpoint. Well, what does a midpoint tell us? Well, if C is the midpoint of BD, then we know that BC is going to be equal to CD. It cuts it in half. So BC is going to be congruent to CD. Okay, next statement is that angle ABC and angle EDC are right angles. Well, this is by definition of perpendicular line. Again, I'm going to shorthand perpendicular and use the capital T upside down. Then lastly, it says that the triangles are congruent. So how is triangle ABC congruent to triangle EDC? Well, it's because they have two hypotenuse that are congruent and they have legs that are congruent. So it would be by the HL theorem. And that concludes this section.